Welcome to quicktechie.com, Palo Alto Networks, Network Security Generalist Certification Training. Let's dive into next module.
SSL Inbound Inspection. Let's talk about something called SSL Inbound Inspection. Imagine your company has a website or an application that people on the internet can visit, like your company's online store or a customer portal. This website or application is hosted on a server inside your network. When someone visits this site using a secure connection, HTTPS, the traffic is encrypted. It's like a sealed box coming into your network, heading for your server. This is inbound traffic. The problem is, bad guys can hide threats like attacks, exploits, or malicious code inside this encrypted traffic, specifically targeting your internal servers. Without opening the box, your firewall can't see these threats. SSL Inbound Inspection is the process the firewall uses to open and check these encrypted boxes that are coming into your network, heading towards your internal servers. How does it do this? Unlike the outbound decryption where the firewall makes a new certificate, for inbound inspection, the firewall needs a special piece of information from your internal server, its private key. Think of the private key as the unique key that only your server has to open the encrypted boxes sent to it. You give a copy of this key to the firewall. With the private key, the firewall can receive the encrypted traffic meant for your server, use the key to decrypt it, open the box, and then inspect the content inside. This allows the firewall to look for those hidden threats, like attacks trying to break into your web server or malicious data being uploaded. After inspecting, the firewall can decide if the traffic is safe to send to your server. If it's safe, the firewall usually passes it on, often re-encrypted, though the exact flow can vary. If it finds a threat, it can block it. So, in simple terms, SSL Inbound Inspection is about checking encrypted traffic that's arriving at your doorstep, your internal servers, by using the specific key, private key, for that door, to make sure no bad guys are hiding inside before they reach your valuable internal systems. Used for encrypted traffic coming into your network towards internal servers, e.g., hosted websites, let's focus on when we use SSL Inbound Inspection. Imagine your company has its own computers and systems inside its network. Some of these systems are internal servers. These servers do important jobs, like running your company's website or hosting a special application that customers or partners use. These servers are located inside your network walls. When someone from the internet, outside your network, wants to visit your company's website or use your application, the traffic flows into your network. This is what we call inbound traffic. It's coming towards your network, specifically towards those internal servers. Just like when you visit a secure website, with HTTPS, the traffic coming to your internal servers is often encrypted using SSL, TLS. It's like sealed boxes arriving at your network's door, addressed to your servers inside. SSL Inbound Inspection is the security process that is used specifically for this type of traffic, encrypted traffic that is coming into your network and is destined for your internal servers, such as those hosting your websites or applications. It's about checking the sealed boxes that arrive at your doorstep before they reach the specific internal server they are meant for. It's not used for traffic going out of your network or for traffic staying within your network. Its purpose is to protect your internal servers from threats hidden in the encrypted traffic arriving from the outside world. Requires the private key of the server being accessed for decryption. Let's focus on how SSL Inbound Inspection actually opens the encrypted traffic that's coming into your network for your servers. When someone connects securely, using HTTPS, to a website or application hosted on your internal server, their computer and your server use something called public key cryptography to create the secure connection. Your internal server has a pair of digital keys, a public key and a private key. The public key is like a lock that anyone can have a copy of. People use it to encrypt messages that only your server can open. The private key is like the unique key that can only unlock the lock created by the matching public key. Your server keeps its private key secret. Only your server is supposed to have it. When an external user sends encrypted traffic to your internal server, their computer used the server's public key to encrypt it. The only way to decrypt, unlock and read that specific encrypted traffic is by using the corresponding private key of the server it was encrypted for. For the firewall to perform SSL Inbound Inspection, it needs to be able to unlock these encrypted messages before they reach the server. This means the firewall must be given a copy of the private key that belongs to the internal server the traffic is heading towards. Think of it like a post office, the firewall, that needs to open incoming locked boxes addressed to different apartments in a building, your internal servers. Each apartment has a unique type of lock. To open a box for apartment 5, the post office needs a copy of only the key for apartment 5's lock. It doesn't help to have the key for apartment 7. Similarly, the firewall needs the specific private key for your web server, or your customer portal server, or whichever internal server is receiving the inbound encrypted traffic you want to inspect. Without that correct private key, the firewall simply cannot decrypt the traffic meant for that particular server, and thus cannot inspect it for threats. Allows inspection for threats targeting your internal web servers or applications. Okay. Let's focus on what happens after the firewall has decrypted the inbound traffic heading for your internal servers. We learned that encrypted traffic coming into your network, especially to your own servers, like where your website is hosted, can hide bad things. Bad actors on the internet want to attack servers. They might try to upload harmful files, malware, that can damage your server or network. Exploit weaknesses, vulnerabilities, in the software running on your web server to gain control of it. Try to steal information that your application handles. These bad things are threats that are specifically targeting your internal web servers or applications. Before decryption, the firewall couldn't see any of this because the traffic was like a sealed box. But once SSL Inbound Inspection decrypts the traffic, opens the box, using the server's private key, the firewall can finally inspect it. Inspection means the firewall carefully examines the content of the traffic. It runs checks to see if it matches known patterns of attacks, if it contains malicious code, like viruses or ransomware, or if someone is trying commands they shouldn't be using on your server. Because the firewall can now see the actual data and commands within the traffic, it allows it to find these threats. If it finds something bad, the firewall can then block it before it ever reaches your vulnerable internal server. So, this inspection capability, made possible by decrypting the inbound traffic, is essential for protecting the servers inside your network that are exposed to the internet from being attacked or compromised. It's like having a security scanner check every package before it reaches the important office inside your building. SSH Proxy. Okay, let's talk about SSH Proxy. SSH, or Secure Shell, is a way for people, often administrators or technical staff, to securely connect to and control a computer or server remotely over a network. Think of it like a secure remote control that lets you type commands on another machine from far away. SSH connections are encrypted, meaning everything you type and everything the server sends back is scrambled and private. However, just like with encrypted web traffic, HTTPS, this encryption can hide bad things. Someone using an SSH connection, even if they are authorized to connect, might try to do things they shouldn't, such as running dangerous commands that could damage the server. Looking for and stealing sensitive information, data exfiltration. Using the secure connection to sneak malicious code onto the server. These are unauthorized actions happening within a legitimate-looking encrypted session. An SSH proxy is a feature on the firewall that deals with this. It's like the firewall becomes a monitor for these secure remote control sessions. Here's how it works. When someone tries to start an SSH session to a server, the firewall acts as an intermediary. It doesn't let the user connect directly to the server. Instead, the user connects securely to the firewall, and the firewall makes a separate secure connection to the server. Because the firewall is in the middle, it can 1. Decrypt the encrypted SSH traffic from the user, open their side of the secure chat. 2. Inspect the commands being sent and the data being exchanged. It checks if the commands are allowed or if sensitive data is being moved. 3. Re-encrypt the traffic before sending it on to the server, and do the same for traffic coming back from the server to the user. By doing this decryption, inspection, and re-encryption for SSH sessions, the firewall can prevent malicious activities like running forbidden commands or prevent data exfiltration, stealing data, that might happen hidden inside an otherwise encrypted SSH connection. It gives security visibility into a communication type that would otherwise be a blind spot. Used to inspect encrypted SSH command sessions for unauthorized actions. Let's focus on why we use SSH Proxy and what it does. SSH is a common way for people, often IT staff, to connect securely to another computer or server to manage it from a distance. It's like having a secure remote control. Everything typed in this session, commands, passwords, data, is encrypted, scrambled, so no one can snoop on the connection. This is an encrypted SSH command session. However, just because the connection is secure doesn't mean everything done within that connection is good. Someone might have permission to connect to a server using SSH, but then they might try to do things they are not allowed to do. These are called unauthorized actions. Examples of unauthorized actions in an SSH session could be trying to delete important files they shouldn't touch, copying sensitive company data from the server and sending it out. This is data exfiltration. Running dangerous programs or scripts on the server. Trying to access areas of the server they don't have clearance for. Since the SSH session is encrypted, these commands and data transfers are hidden inside the sealed box of the encrypted connection. A regular firewall wouldn't be able to see what commands are being typed or what data is being moved. It would just see encrypted SSH traffic and let it pass. The purpose of the SSH proxy feature is specifically to inspect, to look closely at, these encrypted SSH command sessions. The firewall, acting as the proxy, can open the SSH box, decrypt the traffic, look at the actual commands being sent and the data being transferred, and then reseal it. By inspecting, the firewall can identify if someone is attempting unauthorized actions within their secure session. If it detects a forbidden command or sensitive data being copied, it can then stop that specific action or even block the entire session. This allows network security to monitor and control what happens inside SSH connections, even though they are encrypted. Firewall acts as an intermediary, decrypting SSH traffic, inspecting commands, data, and re-encrypting. Okay, let's break down exactly what the firewall does when it acts as an SSH proxy. Imagine you, the user, want to connect to a server using a secure remote control session, SSH. Normally, your computer would create a direct, encrypted connection to that server. With the firewall acting as an intermediary, it means the firewall steps into the middle of this connection. Your SSH client, the program on your computer, connects securely to the firewall first, not directly to the server. Then, the firewall makes a separate secure connection from itself to the server. Because the firewall is sitting in the middle, it can perform these steps. 1. Decrypting SSH traffic. When the encrypted SSH traffic, like your commands typed into the remote control, arrives at the firewall from your computer, the firewall uses its setup to open this encrypted session. It unlocks the sealed box and can now see the commands and data in plain, readable text. It also does this for the traffic coming back from the server to you. 2. Inspecting commands, data. Once the traffic is decrypted inside the firewall can inspect it. This is the crucial security step. It looks closely at the actual commands you are sending, like delete files, or copy customer data, and any data that the server is sending back. The firewall checks this against its security rules to see if these actions are allowed or if they look suspicious, like trying to steal data. 3. Re-encrypting. If the inspection finds nothing bad and the traffic is allowed to continue, the firewall doesn't just send the readable text onwards. It takes the cleaned and checked commands or data and puts them into a new encrypted, sealed box. It re-encrypts the traffic for the second part of the journey, either from the firewall to the server, or from the firewall back to your computer. This keeps the communication private between the firewall and each endpoint. By doing these 3 steps, acting as the go-between, opening the encrypted box, checking what's inside, and then sealing it back up. The firewall allows security inspection of SSH sessions that would otherwise be invisible because of the encryption. Prevents malicious activities or data exfiltration over the SSH protocol. Okay, let's focus on how the SSH proxy helps stop bad things. Remember that SSH is used for secure remote access, like controlling a server from a distance, and these connections are encrypted, like a sealed box. But even though the connection is secure, someone might try to use it to do harmful things. These harmful things are called malicious activities. This could be someone trying to run commands that are dangerous for the server, like trying to install malware, change important settings they shouldn't, or damage the system. Another bad thing is data exfiltration. This means secretly copying sensitive or important information from the server and taking it out of the network without permission. Imagine someone using the secure SSH connection to copy confidential customer lists or company secrets from a server. Because the connection is encrypted, this data theft could be hidden. The SSH Proxy feature on the firewall prevents these things from happening. How? Because the firewall acts as the intermediary, it's able to decrypt, open, the SSH session and inspect the commands and data being sent. It can look at what commands are being typed. It can look at the data being transferred. If the firewall sees a command that is on a list of forbidden or dangerous commands, a malicious activity, or if it detects that sensitive data is being copied out, data exfiltration, the firewall can stop that action. It can block the specific command or shut down the entire SSH session, preventing the bad thing from happening. So, the SSH proxy's ability to see inside the encrypted SSH connection allows the firewall to actively prevent people from carrying out harmful actions or stealing data over that protocol, even if they successfully made an encrypted connection. Functionality in Strata and SASE. Okay, let's talk about functionality in Strata and SASE. Strata and SASE are names for the security platforms offered by Palo Alto Networks. Think of them as the different ways you can use Palo Alto Networks security tools. Strata primarily refers to their physical or virtual firewalls. These are like the security checkpoints you install in your network to control traffic going in and out. SASE, which stands for Secure Access Service Edge, is a newer approach where many security functions, including firewalling, are delivered from the cloud. This is often used for securing users and devices connecting from anywhere, not just from inside the traditional office network. The concepts we just discussed, SSL Forward Proxy for outbound traffic, SSL Inbound Inspection for traffic coming to your servers, and SSH Proxy for secure remote command sessions, are decryption capabilities that are built into these Palo Alto Networks platforms, both Strata firewalls and SASE cloud services. Why do these platforms have these capabilities? To gain visibility. Visibility means being able to see what's really happening in the network traffic. Without decryption, most encrypted traffic is invisible, like sealed boxes. By using these decryption methods, SSL Forward Proxy, SSL Inbound, SSH Proxy, the Strata firewalls and SASE cloud services can open the boxes and see the actual data and applications inside. This ability to see inside encrypted connections extends deep security inspection. Deep inspection means looking closely at the actual content, not just the traffic's basic information, like where it's going. These platforms can apply advanced security checks, like looking for specific malware signatures or detecting complex attack patterns, even within encrypted flows. It's important because network traffic isn't only outbound web browsing, which SSL Forward Proxy handles. Traffic also comes inbound to your own servers, SSL Inbound Inspection, and includes things like secure remote management sessions, SSH Proxy. Strata and SASE give you the tools to decrypt and inspect these different types of encrypted connections too, providing comprehensive security coverage. So, these decryption features are core functions available in Palo Alto Networks Strata and SASE products, enabling them to see and secure encrypted traffic beyond just standard web browsing. These are distinct decryption capabilities offered by Palo Alto Networks platforms. Okay, let's talk about These are distinct decryption capabilities offered by Palo Alto Networks platforms. We've talked about different ways to handle encrypted traffic, SSL forward proxy, for when users inside your network go out to websites. SSL Inbound Inspection, for when people from the internet come into your network to reach your servers. SSH Proxy, for secure remote command sessions. These three methods are ways that security devices can open the sealed box of encrypted traffic, but they work in different situations and sometimes use different technical steps, like needing a server's private key versus generating a certificate. Because they are different methods for different purposes, they are called distinct decryption capabilities. Distinct just means they are separate and different from each other. Now, Palo Alto Networks platforms refers to the actual security products that Palo Alto Networks makes. This includes their physical firewalls, often called Strata, and their cloud-based security services, like those in SASE. So, when we say, these are distinct decryption capabilities offered by Palo Alto Networks platforms, it simply means that the different methods we've discussed for decrypting various types of encrypted traffic, like outbound web, inbound to servers, and SSH, are features that you can find and use within the security products built by Palo Alto Networks, whether those products are physical firewalls or cloud services. These capabilities are not all the same. They are different tools designed for different decryption jobs. Strata, firewalls, and SASE, cloud, products apply these techniques to gain visibility. Let's focus on Strata, firewalls, and SASE, cloud, products apply these techniques to gain visibility. Strata means Palo Alto Networks firewalls. These are security devices that sit in the path of your network traffic. SASE refers to Palo Alto Networks security services delivered from the cloud, also designed to sit in the path of traffic, especially for users who are not in the main office. These Strata firewalls and SASE cloud products are the tools that apply these techniques we've been talking about, like SSL forward proxy, SSL inbound inspection, and SSH proxy. They are configured to perform these decryption methods on the network traffic that flows through them. Why do they do this? To gain visibility. Visibility in network security means being able to see clearly what kind of traffic is moving, what applications are being used, and what data is being transferred, even if it's inside an encrypted connection. Remember how encrypted traffic is like a sealed box? Without decryption, the firewall, whether it's a Strata firewall or SASE cloud service, only sees a sealed box. It doesn't know if it contains a harmless website, a dangerous virus, sensitive data being stolen, or an unauthorized command. By applying the decryption techniques, opening the box, the Strata and SASE products can now see inside. They gain visibility into the actual content of the traffic. This allows them to perform their core security functions effectively, like detecting malware, preventing data loss, and controlling applications. So, the point is that Palo Alto Networks security products, Strata and SASE, use these specific decryption methods to remove the blindfold of encryption, allowing them to see the traffic content and apply necessary security inspections. Extends deep security inspection to different types of encrypted connections beyond typical outbound web browsing. Let's focus on the idea of extends deep security inspection to different types of encrypted connections beyond typical outbound web browsing. Deep security inspection means that the firewall doesn't just look at the basic information about network traffic, like where it's going or coming from. It actually looks inside the traffic, at the content itself, to find threats like malware, or to see exactly what application is being used. Normally, encrypted traffic, like SSL, TLS, or SSH, is like a sealed box. Without opening the box, decrypting, deep inspection is not possible because the content is hidden. We often think about decrypting encrypted traffic when users inside the network go out to secure websites. This is outbound web browsing, using HTTPS, handled by SSL forward proxy. This is one common type of encrypted connection. But internet traffic isn't just outbound web browsing. There are different types of encrypted connections. For example, encrypted traffic coming into your network to reach your internal servers, SSL Inbound Inspection. Encrypted sessions used for securely managing servers remotely, SSH Proxy. Other applications might use encryption too. Without the right tools, the firewall would be blind to the content inside these other types of encrypted connections. Threats could hide there, and the firewall couldn't apply its strong security checks. The Palo Alto Networks platforms, by having distinct decryption capabilities like SSL Inbound Inspection and SSH Proxy, in addition to SSL Forward Proxy, make it possible to open the box for these different types of encrypted traffic. This is what is meant by extends deep security inspection. It takes the powerful ability to look inside traffic for threats and applies it to more than just the typical outbound web traffic. It stretches that deep checking capability to cover the encrypted traffic that's coming into your servers, the encrypted remote management sessions, and potentially other encrypted application flows. This gives a much broader view and stronger security against hidden threats across your network traffic.